All right, so first thing I want to do is make sure we do a quick review of functions. So I'm actually just going to step back to our last class. I didn't copy any extra notes over, but let's go over these sort of basic concepts of functions, return values, parameters, just for review again. And then we'll pretty much spend this class talking about some high-level concepts of programming. And if we have some extra time at the end, we'll get into talking about scope a little bit more. We just touched on it briefly at the end of last class, and we might start talking about the difference between references and values in variables in programming languages. So to review, a function is just a group of statements that perform a task. They're grouped in JavaScript. The way that you define them, or the canonical common way, is to use the function keyword followed by the name of your function and parentheses. Within the parentheses, you put your, does anyone know what you put inside of your parentheses if they have them for a function? Your arguments when you call it. Do you know what they're called when you're defining it?
Oh,
parameters. Yep. So you put your parameters there, and then you have your curly braces, which defines the block or the scope of the function, and any statements that you want to run inside of your function in there. So that itself is, I think, pretty straightforward. Then make sure I'm going over the times I wanted to. So all functions, it doesn't matter what the function is, every function returns a value. However, if you don't have an explicit return statement inside of your function, which we just saw, then the return value from your function is going to be undefined. Yep. If we don't have a return statement telling us exactly what we're returning, for example, in this print hello, then the function is going to return undefined. So if we want to return an actual specific value from our function, we use the return statement, followed by whatever we want to return. And that can be, in this case, that's just the string directly, but you can have a variable, for example, that you return. And when you return a variable, what it will actually return is the value. It'll get confusing later today, but the value of that variable, not the variable name itself or anything else. And then we already talked about it a little bit, but functions have parameters or can have parameters. And those parameters are like local variables inside of the function. They're accessible inside of your function using the name of the parameter. So in this case, there's a name parameter. And then when we call the function, you call it with an argument that maps to that parameter. So we're calling this one a couple times in our code here. We've got say hello, and we pass in the string Jared for our argument. So that's equal to the name parameter when that function runs is Jared, and then we call it with Noel. Any questions about functions?
That's where I got a little confused right there. It goes in that one you don't have it. And do that
Yeah.
name. That's why it was messing me up.
Yeah. I moved back and forth between the two because you can do it either way, right? And one thing I think, let me make sure I'm consistent here. One thing you might notice is I named my functions differently depending on what I was trying to do with them. So if we go up to the top here, and let's see, I may prove myself to be a liar, but I hope I'm not. In this one, I called it print hello. So I'm trying to indicate that this function is pretty much has a side effect. It's printing something to the screen directly, right? And then, all right, I still have this is print hello because it has this side effect. And in this version, I changed the function name to get hello. And what I'm trying to, this is a little bit of just convention for programmers. It's something that when you've been in programming, you sort of understand what this means. Get tends to mean get me something back. Like I'm going to go get something from the store. And so what this is getting is hello world. And that's why this one's returning it as opposed to printing it directly. He's saying, get hello world, and then I'll do something with whatever I got. And you can see I stick with that here, showing the same thing. And then I sort of with it here too, because this is still just returning it, but using a local variable. But then in this one, I switched it back around to say hello, or it could be print hello again, sort of indicating that I'm not getting something back from it that I care so much about. This function is doing something as opposed to returning hello to me. So there's a little bit of just convention of names there. That's a pattern that's pretty common, is indicating your function by a lot of times when you're writing a function, functions are taking actions of some kind for the most part, right? They're doing something. And so a lot of function names will be composed of a verb followed by like a noun or something like that that you're trying to describe it on. So you can see these are like say or print or get. That's our verb saying what's our function doing, sort of communicating something to us. And then the thing that you're working with or taking action on, hello. Another very common example of that sort of syntax for a function would be is true or something like that. So you're trying to say like, and we'll do this as a homework assignment. I just haven't written it up yet. Is odd. So before I write anything else for this, if someone were to guess just based off the name of this function, if we were to call a function is odd, what do you think this function might do?
Is it looking at whatever argument you put in and stating whether it's an odd integer or...
Yeah, that's pretty much what you might think it would do. And so that's why having descriptive names is very useful, because just by this name, I've written no code. Nobody's looked at any code behind this. And yet you could look at this and get a pretty good feel for what you think this function is going to do. And then if I told you this much of it is odd number and say, oh, it takes a number as a parameter or an argument, then now it's really starting to indicate, oh, this is probably returning something, trying to decide if that number is odd or not. And by convention, usually with something like is, you're usually returning a Boolean value, like yes or true or false on whether or not it's odd. But that's just, we can go through a whole bunch more examples of that. That's sort of just a convention. You really could name it whatever you wanted. It's just a useful way to know what it is. I could name it function foobar. And that tells the only problem with that is that doesn't tell me anything about what's going on in there. Any other questions or confusion about functions so far?
Can we go over the voting age one? Something similar to that?
Ooh, yeah. Let's solve this voting age one. That was one of our. I just put it into the homework recently.
Can you see what I have saved to see if it's even close to that? Because I put in 2 different arguments and I can get the return. I just can't tell the return to change it to a Boolean.
Yeah, I should be able to. Let me check. You want me to show everyone?
Yeah, that's good. This is like my 20th version.
All right, let's see. Let's see what we got here. Oh, come on, load up. All right, where are we at here? Where are you? There we go.
It shows a draft on my end.
Hmm.
I'm not showing it.
I
can submit it just so you can see it.
Yeah, why don't you submit it, and then I think I'll be able to see it. Oh, there we go. Look at that. That was like instantaneous. Yeah, if you submit when you're having a problem, then it tells me that you're awaiting help.
Okay.
Oh.
And then I'm able to like write a response like I did with Faith and stuff, and say like, oh, here's some suggestion. I'm not going to promise that I get to that right away, But if you click that submit button, then I'm able to see what you've worked on and able to give you some comments or response back.
So if you run it, one will tell you they're old enough, one will tell you they're too young.
Okay. Pretty much everything in your code is right, except for
I can't turn it into a Boolean.
You're not returning a Boolean.
So instead of returning a phrase, you want Boolean, and it's smart enough to say true.
Well, if you do this, you can. Booleans are like the Boolean variables are keywords. That's the word I was looking for. Are keywords in the language, right? So so if we go down here to our, you can type true because that's a valid keyword. And if you did type of true, it'll tell you it's a Boolean. So here you could literally just return like true. I can't change your code, but you could return true and return false.
Might be something as simple as that, and it still filled it. Does it have to be in the quotations? Is that what I did wrong?
Oh, it shouldn't be in quotations because it's a keyword. So you don't want to. Quotations would be a string. So if you do like,
I don't think it's letting me change it.
if you do like quote true, if I did type of true, for example,
Okay.
it'll tell you that's a string.
Instead of a Boolean.
But if you did type of true just directly, it sees that as a Boolean. All right, let me step out. There you go. I mean, that's a good one. I think people just saw it, but we can easily write that one again here in class because it's a little bit. There's always the possibility that I've written my test wrong too, but.
Well, I might have put it in a quote or parentheses, thinking that might have been it. I know at one point it was just an unexpected token.
Yeah.
But I was getting true as undefined, and then I rewrote it. And then I don't remember the other one, but the majority of the errors I was getting was unexpected token on my last console log. I've broken the keyboard.
So if we were going to write this, I know we just had it up on the screen. Maybe people already forgot. If we were going to write this, and we want to write a function for is voting age, it'll return true if the person's a voting age and false if they're not. What would be our first step if we already have a function, we already have an age getting passed in, and we know that the voting age is 18? If the age is greater than 18. All right.
Question. Why does age greater than or equal to 18 have to be in parentheses?
Why does it have to be in parentheses? Just because an if block in JavaScript puts its conditional in parentheses. So I could be mistaken here. Let's check. You can see it's like this thing's already complaining to me. It's like, I don't know what to do. It's because it's sort of how it delineates. Here's my condition for my if block. Here's what I know I'm checking against. So in this case, it was able to look at that condition because otherwise it doesn't know where that condition begins and ends. What am I trying to decide if it's true or not? That's really the only reason. There are some programming languages that don't require that. But yeah, it's just the syntax for this. So if the age is greater than or equal to 18, what do we want to do then? Return true. All right. And what do we want to? Do we want to have any other? Looks good to me. We can try some of these and see what we get. Console.log. Right, I can put a few more of these in and try them. 17 and 1, for example. Oh, I have a problem in mind. Where is my issue?
Do you need the console.log?
I don't need it. I just wanted to be able to see the results because otherwise it's not actually going to write them out since it's in a file in this case.
Oh, okay.
Because the other, it doesn't show you the result of evaluating each expression when you run a file. It only does that when you're in one of the read eval print loops. And that's so that you can see what's going on, you know, get that visual feedback. What do I have wrong here? Oh, I know what's wrong. I'm not in the right folder. There we go. All right.
So I changed mine and it does the exact same thing, but it's still failing when I submit it.
All right, let's take a look.
So I'll submit it as it is.
Oh, everyone's finishing it now. Yeah, I see. Ah, yeah. There is something different here. Your is voting age is not using the same case. So the V is lowercase. So when the code I wrote to test this, it's called, function names are case sensitive. And so I'm trying to call is capital V voting, capital A age, like, and so it tries to call that function doesn't exist for it to call. It's like, aired out, I can't call this function to test. So,
crazy.
Yeah. That's why it's failing.
Okay.
And we're going to have, again, a lot more of these are going to be coming along, building off of what we already have. Now let me ask a question. Can anyone see like a problem, or could somebody maybe put some value into this that might cause issues with this function? I'm going to take this and run it in our read eval print loop so we can just test it more rapidly with different values. Is voting age, we can do 18 just to make sure we're working as expected. All right. What if we did is voting age -4? A little weird. I mean, I'm not saying that we've done anything wrong with this function. This function is doing exactly what it says it should do in some respect, but might ask the question, do we want to worry about that case? What happens if somebody passes in a value like that? Do we want to have some sort of logic around it at some point? Do we want to tell them, hey, this isn't allowed? You gave us a negative value. You can't be a negative age. Might try, what if we did is voting age hello? Like what happens? I mean, that seems logical. That's not a voting age, you know. But
We have number, no, not string.
what?
We have numbers.
Yeah.
It's not string, so false.
So it's false. Yeah. What about here's an interesting one. Is voting age 18? We think it's going to happen with that one. Anyone know? What?
True.
Should be true.
True?
Yeah.
Why is that?
The equal to.
Equal to.
Because it's converting the type. Yeah, it's converting from a string to a number when it does that comparison. And it's doing the same thing with hello, by the way. The only difference is if we did parse int of hello, response is this is not a number. And if you did parse int of 18, you get 18. So that's really what's going on there. But that's one of the things that you need to think about when you start getting into writing functions, is you got to start thinking about all of the different edge cases of what happens in this. What if somebody passes in these different values that I didn't plan for? Like, should I handle it when somebody passes in a negative number? Should I do something different in that case? Should I do something special in, you know, these other cases? Should I give some sort of message? There are some mechanisms, and maybe we'll get into them. But you've seen errors in the programs that you've written already, right? You've seen the console throw errors at you. You can actually do something called throw error yourself. I think I did that wrong, but you can throw an error. Oh yeah, it's uppercase, I believe. Which will cause your own error to occur. And I wouldn't worry about that too much, but it's a way to deal with some cases when something isn't what you expected. So for example, let's expand this is voting age now. Let's say we only want to return false for ages now between like 0 and 18, and then we want to do something else. Don't worry about it right now for anything beyond that. How would we change this? If else, yeah. It's else if, but it doesn't matter. Syntax is not a big concern. So else if.
Less than 18.
Age is less than 18, except we only want to do this false for between 0 and 18.
And greater than. Equal to or less than 17.
And age is greater than 0. Should we greater than or equal?
Oh, yeah.
All right. So now if we had that, let me just copy that down here into our redevel print loop so we can test it more rapidly. Is voting age. If we tried 18, we should still get true. And like 17, we should get false. And let's try 0, false. What are we going to get with like -1 now? Yeah. Good answer. It's because it looked at those, it didn't match either of those cases, so we never ran a return statement. And if you don't run a return, your function returns undefined. But we could, and this is just, I wouldn't expect you guys to do this right now, don't worry about it. We could do something like this instead. Throw error. Like just throwing an error when this happens instead now of some kind. Again, this is just showing you how to deal with some of this stuff, but not something you need to do right now. Now if we did is voting age of like -1, it threw an error that looks a lot like the errors that we were already seeing when we made a mistake in our code, except we manually told it, this is an error. You put something in here that's not legitimate input. All right. Any other questions on the homework assignment right now. Again, I'll go over with some more with some other people after class if you want, because I want to leave some time. So then I just had a few higher level concepts to talk about today, and maybe we'll get into scope and reference, but I want to leave about 30 minutes at the end of class. So if people want to work through any problems that they've specifically had, I've got time to work with you. So we're starting to get into functions. We're starting to get into more complex programs where we're composing these different aspects of programming. And I wanted to talk about some of the tools and ways to think about stuff that we as a software development industry, as programmers, use that allow us to build these much more complex programs. Because everything you've written so far has been, what, maybe 20 lines of code or something like that? All pretty small in this class. If you were to take a guess, how many lines of code, I don't know the answer here, how many lines of code do you think are in, say, Windows, the operating system? What? Too many?
1,000 and 1,000.
What?
Tons of million. Tons of thousands.
I don't know the answer. Let's see. Lines of code in Windows 10. Let's see. What about, let's try Linux. This is another one. 13 million lines of code kernel. Oh wait, it grew from 13 million to 15 million. This is around 2012. I'm sure it's grown a lot more since then. So can you guys imagine trying to work with a code base that's 15 million lines of code and understanding how to do anything in there? Right? It's impossible. At least especially if you're trying to think of the whole thing all at one time. If you're trying to know how all of it works, you're never going to be able to do that. And there's no one person who understands all of the code in Windows or all of the code in Linux or any really large program. And even by the time you've gotten up to 1,000 or 2,000 lines of code, nothing massive, but a decent amount, it becomes very, very hard to think about all of that code at once. Almost impossible. Heck, by the time you're at about 100 lines of code, it's almost impossible to think about all of it at one time and all of the ways that can interact and work together. And that's why there's a lot of tools and a lot of ways of thinking that exist to help you work with these larger bodies of code and accomplish tasks at a much larger scale. So the first major thing to think about, and I've talked about this a little bit in terms of functions, is abstraction. Abstraction is really just the idea of hiding complexity by providing a simpler interface. So instead of having to know how everything works behind the scenes, you get to work with a very simple interface, and all the complexity of what's going on behind the scenes is hidden from you. So some really good examples of this. Also another great thing, I like this point I made, that common interface can be used to interact with systems that operate very differently internally. So you can use this same common interface, and yet inside something entirely different might be happening. So some good examples are a steering wheel in your car. Who knows everything that's going on under the hood when you turn the steering wheel on your car? Nobody, right? I'd be surprised if anybody did. There's a lot that takes place, and it can vary dramatically from car to car. In some cars, it's known as steer-by-wire. So the steering wheel isn't directly connected to any mechanical pieces. It's just connected to some electronics that somewhere else in the car are making these movements. But in, especially a lot of older cars or, more basic models, you have a direct mechanical linkage. So when you turn your steering wheel, there's some gears moving left and right and turning your wheels directly and changing how your wheels turn and all of that. And that's a lot of complexity. And none of you know how that works underneath, but you're all able to work with it without any problem. That's the concept of abstraction. When you abstract away all that complexity and you get to work with a much simpler interface. That's what one of the major things that functions do for you, is they abstract away the complexity inside of them and you get to work with a simpler interface. And some other great examples of abstraction that most people would be familiar with. A video game controller is a great example of abstraction because each video game works totally differently. That controller does something different in every game that you play, but you're able to use this same input method to play a football game and an RPG and a first-person shooter. And it doesn't matter that those inputs do something totally different. It doesn't matter that it's a very different experience in terms of what's going on. They've abstracted that all away to just these buttons and direction pads and turning and stuff like that, right? And then web browsers are a good example where there's so much complexity that pretty much nobody knows everything that goes on when you make a simple request to a website from a web browser. And yet we're all able to interact with them very easily. In fact, this is something I ran across just recently. There's literally a GitHub, a code page site that has gotten really popular in the past couple weeks of what happens when you type google.com into your browser and press enter. Because you're thinking, this is something very simple. I just typed google.com, right? And this is an attempt to break down, like, this is just the table of contents of what's going on your system when this happens. Right? Like, that's an abstraction. That level of complexity is amazing, and yet you guys don't have to worry about everything that's going on there. So that's one of the core aspects of being able to work with larger programs, is being able to learn to deal with abstractions and not with the underlying mechanisms, right? JavaScript is an abstraction on top of lower level programming languages, on top of assembly language, on top of binary, which is what your computer speaks at the lowest level. The next sort of aspect of being able to work with programs, and this is also something that's very well represented in the concept of functions, is algorithms. So we work with abstractions, and one of the most common abstractions we have is an algorithm. An algorithm is just a process or set of rules to follow to solve a problem. So you guys are all familiar with algorithms in different ways. You may just not have called them that before. Anyone here has ever cooked anything following a recipe? Yeah? Just about everyone, right? A recipe is an algorithm. It tells you, here are the inputs that you need. You need this much of this ingredient, this much of that ingredient, this much of this ingredient. That's very much like arguments to a function or parameters to a function. And then the recipe has a certain number of steps that it goes through. Take step, this step, this step, this step, and then your output is whatever you were cooking. So an algorithm is just a series of steps or rules to follow a problem. And functions are a great way to sort of encapsulate this. Other great examples are like tying your shoes. You've got algorithms for how to tie your shoes, you know. Some people do the loop, swoop, and pull thing. I literally failed that in kindergarten. I was never able to do it. So like I had to do, you know, I had to learn to do like make two separate bunny ears and then tie them around each other. And so I had a different algorithm. And if anybody's interested in my own little minor geeky thing, one I learned much later in life was a one-step smooth like algorithm for tying my shoe, right? It's the same thing. And then algorithms, that maps over to algorithms that we've worked with already in class, right? We've built an algorithm for finding the longest string in an array in one of the classes we had the other day. That was an algorithm we had. How can we find what the longest string out of this array is? Or sorting an array of numbers would be an algorithm. How can you sort an array of numbers? That's probably an assignment that we'll have. Functions. We're reaching this point where we're going to start building something larger, not these small one-off tiny pieces, is composition. So if we've got things that we can abstract away and we know how to put together a set of steps into an algorithm, the next thing that we really need to be able to do is know how to take these different abstractions, take these different algorithms and compose them together and build something larger out of them. Because having one algorithm that has all the steps is way too hard to do. Instead, what you want are smaller pieces that get built up together. So good examples of composition in the real world. Again, I always try and map this stuff back so people can try and think of them outside of the realm of just programming. Like a symphony is a great example of something that's a composition. You have all these different things, like the trumpets and the violins and the flutes are all doing their own thing. And they're just doing it themselves, but together you get a much more complex composition out of each one of those individual pieces. No one person would be able to understand everything going on there. Even the composer, just has a broad feel for what each group is supposed to be doing. But by having each one of those focus on their aspect and then putting them together, you get to build something amazing. Another great example are Legos, right? You build really complex stuff out of Legos. Let me see if I can find the reference I used last time I did this, I think. And the internet seems slow today. A video that we looked at sort of last time I was teaching this. This is composition. These are them using all of these small building blocks and different levels of pieces and building something much larger out of them. And I love it because this is a really good example to me of what programming is like in the day-to-day world. You're not building stuff, just completely from scratch, and you're not having to do everything all in one place. Instead, you're taking a whole bunch of different building blocks, some that you build yourself, some that came from somebody else already, and putting them together to build something much larger out of them. So I think it's important when you're thinking about software development and thinking about programming is we take this next step into complexity and what we're building to remember these concepts. Don't try and imagine everything all at once. You're never going to be able to hold all of it in your head. You can't. You have to think about small pieces. You have to think about what's a small piece I can build, and then how can I put that together with other pieces? You have to think about how can I abstract this complexity so that the next time I work with this, I don't have to think about how to solve this problem again. I can just have it solved and work with the higher level interface. And then when you're down in there building these pieces, you have to think about the algorithms of what are the steps, what's the order, how do I get all that correct? All that, makes sense. Does that help at all, thinking about how to work with programming? Yeah. Awesome. Let me see here. So we got a little bit of time left. So let's talk a little bit more about scope, and then I'm going to talk a little bit about reference versus value differences. Something that we haven't really discussed at all yet, so it'll be a little confusing at first, and it'll definitely be something that we're going to work through a lot more with scope and references and all of that. Scope, we talked a little bit about it yesterday or last class in terms of function scope and global scope, but scope is just the area within a program that a variable is accessible. Methods, and it says methods on here, replace that with functions in your thinking right now. Methods is a sort of interchangeable. Methods create their own scope. And the code outside the method doesn't have access to the method's scope, the function scope. So code outside of it doesn't have access to variables defined inside of that function. The parameters of a function are temporary. The variables defined in it are temporary for within the scope of that execution of that function, and they cease to exist after we exit it. But you do have access to the variables sort of defined outside of a function in a function scope. Those are just in a different scope. You have access to them as long as you haven't shadowed them by a variable with the same name inside of your function scope. So if you've used a variable with the exact same name, then, or a parameter with the same name as something from the external scope, then you don't have access to that external one because it doesn't know how to get there. It checks for that variable name. It says, oh, I found something, and it gets the value. You can't step outside to the external scope. But if you're not using something with that same name, it'll check the external scope as well for those. So to do another hands-on example of that, since we talked a little bit about it last time, let's create a variable. We'll call it foo, and we'll just put the string foo bar in there or whatever. And let's create a function, bar. And inside of here, we'll also create, well, let's not. Let's just do console first, console.log foo. If we call bar, it's able to access this foo variable, even though it wasn't defined inside of this bar function. And that's because when it goes to look for foo, it first checks inside of this local scope of bar. It says, all right, I have no foo variable. It doesn't exist. So then it checks the outer scope, finds foo, and gets the value for it. But if we change that, let's make another function. Function, let's call it shadow. And in here, we'll create a foo. And then we'll assign that to something. Now, if we call this function instead, then what it's going to print with its console.log is shadowed. And that's because when it sees this console.log foo, it first checks the local scope for any variable named foo, and it finds one. It finds this foo here and gets the value of it. And that's what it's going to print out. So it never sees it's termed as shadowed or whatever. Like it doesn't have access to the foo in the external scope anymore because it doesn't know how to get that name of the foo out there. Like it can't get a reference to it that is unique because when it did the foo here, how would it know something? There are ways to do that, but in this case, it doesn't work. And then one last example again to show like just hands-on methods. If you define something inside of a method or a function, that the outer scope doesn't have access to it. So let's say we have function local, and this will define we'll do food. Food equals pizza. We'll do console.log food. You get more fun. Favorite food is food. So we can run this. My favorite food is pizza. But out here in this outer scope, food is not defined. And that's because it only exists inside of executions of this local function. It won't exist external to that. So as soon as it's finished executing local, every time it runs it, it essentially every time it runs it, creates a local variable called food with the value pizza, and then once it's done, it frees up that variable, that memory. So that's not accessible anymore. And there's probably a little bit of confusion around that, but does that generally make sense? Yeah? Any specific confusion people have? Any examples that somebody wants to see, or examples that they're not sure what it would do? No?
Is there another way you can explain it?
Another way to explain it. Yeah, let me try and use the whiteboard. I think I did a bad job of whiteboarding this out last time. So I think I can do a better job. If you were to imagine that this here is the scope of your entire program in a sense, right? Or the larger scope. So here, let's say we create this, I'm just going to use food as my examples. So if we have a food variable, and this is, you'll see probably a lot of code sort of written out this way when they're showing how variables work and stuff. You can imagine that this is supposed to look a little bit like the memory on your computer, where it's like these are just memory locations, somewhere to put something. So if we have a variable food here, and it points to this, which says like pizza, and then we have a function that we call, right? Print food or something. Essentially, when you call this function, what this is going to do is create another section inside of memory, almost like this whole, like the entire program. And this is going to have its own little array of memory. And if we have a food reference in here, we can have a different value here. Cookie might be what it has. So this is all, let me make this go a little wider. When we call like print food here, it creates this extra scope down here. So now let's add another one up here, another variable. We'll just call it, I don't know, number. And it'll be 42 over here, right? So if you're inside of this, a call, if you've called the print food function, it's going to create this scope, and it creates a local variable called food that has cookie. So anywhere inside of here, if it's looking for a variable named food, it's first going to check this. It's going to say, oh, I found it. I'm done. But if inside of here it's looking for a variable named number, it's going to look at this list and go, I don't have that. It doesn't exist anywhere in here. All right, let me go up to the scope above me. The scope is basically what called me, and look for it. All right. Oh, I see number up here. That's what I can use as a value. And then when this call is done, so when it exits this print food function and has returned from it, then this whole scope gets deleted completely, freed up, and you have no access to it anymore, and you're just back up at whatever level you were at here. I don't know if that helped.
I got confused in where you said that whole thing gets deleted. Why did it get deleted? Others.
Why did it get deleted?
Yeah.
Yeah, I understand why that can be confusing. I'm trying to figure out how to explain it. Let me think here. Essentially, every time you call the function, that's when it creates that sort of scope, and when it exits that, it deletes all of that information. That's a good example. I can't think of great examples. I'll swear right now. I'll have to think for a minute and see if I can come up with a good reference example of what that would be like in a different context. I don't know. That's tough. That's a tough one. It's a little bit of a tough concept when you're first getting introduced to it, anyways. Yeah, I'll have to think about that. See if I can get a better example, because I can understand where there would be confusion on that. It makes sense to me that it's a little puzzling. Let's give another example, and this will get much more complex. So it might be a little confusing. I think it's good to get some confusion over some of this stuff, and then maybe get some clarity later. Actually, I don't know if I can do one of these correctly on the fly. I'm probably going to screw it up if I try and write this. Let me see. Let me see. Yeah, I'll have to come up with. I don't want to be too confusing, so I'll have to come up with something later as a reference for what I'm trying to do right now with that. Any other questions on scope right now? No?
What happens, like, say, if in the bigger scope number wasn't there, but it was in that other scope, the smaller scope,
Right.
and you called it from the big one? Give me number. Would it go to the smaller one to give you the number? Like, does it work going both ways, or no?
No, that's what I was trying to show earlier, right? If you define a local variable in a function, anything in the outer scope doesn't have any access to it. That's pretty much a black box to this outer scope. So yeah, if you defined, inside of this scope, if you defined the variable foo, and it's had, say, bar, if there's code out here in the outer scope, so we can write some code. Let's call this function, this is weird, but let's just call it hello, right? So let's say, if you will, our code here is var food equals pizza, and var number equals 42. And maybe we even do some output here. Console.log food, and then we call hello. Essentially what's happening when we make this call to hello is the code, that program jumps over here into this hello, creates this context, this scope, and then runs whatever code exists in this hello function. But it just creates this scope when that happens, right? So then I think it's probably easier to understand why if you had a console.log here and you were trying to log foo, and then let's say we have the call to hello down here, it's probably easier to understand why, well, this wouldn't work because foo definitely doesn't exist, right?
Yeah.
But it might be a little harder to understand why if we put a console.log here, for foo, that it doesn't work. Because you sort of feel like, well, I ran this hello and it created this foo. Why doesn't that exist, or why doesn't that work? And I guess the answer is that this is sort of a stack of contexts. And when you call down into this hello, it it creates this new layer in the stack that it works with and changes. But then when you exit it, when it returns, that layer in the stack sort of ceases to exist. It just disappears. And so when we're here, there would be no foo for this to look at because this sort of layer in the stack doesn't exist anymore. I was thinking more about what could be an example or a reference, and this is not a good one because, boy, let's use one of the most confusing movies you could ever imagine. But has anybody seen Inception? Right? You can imagine if you're at a higher level in the dream, like a higher dream, you don't have access to anything going on at a lower dream. But if you're in one of the lower dreams, you may have access to stuff going on at the higher levels, right? That's a little bit what it's like, I guess. I mean, that's pretty close, actually. Like, that's almost the straight mapping of a programming concept.
Once the hello is returned, the hello function is returned, it just doesn't exist anymore for anything to call into its parameters.
As far as you're concerned, yes. No, what's actually happening, we don't need to spend forever on it, but what's actually happening on the computer is essentially it marks this. It puts like a little thing here that says like this. All of this memory that was being used for this, at some point in the future, you can clean it up. I don't need it anymore and nothing else should ever access it. It doesn't necessarily clean it up immediately. It might just say like, fix that later. And then the computer itself, like a higher level aspect of it, will manage. Now's a good time to clean up all those pieces of memory I don't need anymore. But in terms of the language, none of it's accessible anymore at that point. I mean, almost, but not exactly. It's what's known as essentially a stack. And the idea is that I'm going to pass me some of those Post-its. Yeah, no, several of them. Yeah. So it's like a stack like this. So if you were to think of this as like your initial scope or whatever, this first layer of Post-its, and then when you call into a function, you're essentially putting another item onto this stack and saying, all right, now this is here as well. And then let's say that function, you can call functions from functions. You can do it at any level. So we put another one on there. This function calls another function. And we do that several times. So you sort of got this stack of function calls all taking place. And then when one of them exits, what happens is it just gets pulled right off the stack and doesn't, like, it's not there anymore. And then the next one exits and it's gone and all that context is gone and gets pulled back off and pulled back off. And you don't even have to do it linearly, right? Like you could, all right, so I have my initial code and it calls a function, which calls another function, which calls another function. And now that one returns, and this one returns. And now this one calls another function before it returns. So now so that stack can keep going up and down at any point in time. But as soon as a function returns, all of that is just pulled straight off the stack and gone. All the information and context around it. All right, so we don't have a lot of time for this last bit. I won't go into as much detail as I could. We'll definitely cover it more later. But Another important thing to realize with programming languages, and just most languages have this concept, not all of them, is the difference between a reference and a value. This is where stuff can get pretty complex as you're working within a language, and it takes a little bit to get used to. So we'll definitely work a lot more with this. But a reference is a pointer to a location in memory where a value is stored. And a value is like an actual value. And the reason this makes it matters, the reason there's a difference, is when you're working with the primitive types, and in JavaScript, the primitive types are Boolean, number, string, undefined, null. JavaScript always stores the actual value in the variable. So if you have a string, like food and pizza, and it's a string, that variable has the value pizza, that string. But if you're working with more complex types, that includes objects, it includes arrays, I believe it includes functions. If you're working with any of those, what it actually stores in your variable is not the value of it, but a reference to that set of values or value. And this can lead, I didn't end up getting this stuff written out before class, but this can lead to some very confusing code when you're first getting started with programming, and you end up having to really learn how this works almost over time. So I'll just show a couple examples, again, introducing a concept that will reinforce. Let's look at some strings. So if we have var hello, done this 100 times now, let's do something better. Let's do food. Somebody give me your favorite food.
Fish and broccoli.
Fish and broccoli.
Yeah.
All right. I like this. Did I spell broccoli right? That's right. I'm pretty sure. Fish and broccoli. All right. So food has the string fish and broccoli in it. Now let's create another variable. Let's call it we'll just say food2. We're going to have that equal food. So now food2 has fish and broccoli, and food has fish and broccoli, right? But these have the actual string, like the value stored in these variables is that string for each one of them. So if I change food, I reassign it and I say food equals, now somebody else give me their favorite food. Sweet potato fries. I'm with you. Yeah, with a nice like cinnamon sugar butter or something. Yeah. So now food, storing the string sweet potato fries. And if we were to look at food2, what will be its value?
It'll go back to fish.
Fish and broccoli. And that's because it's storing that string, like it's storing a reference to that string. Now let's show you something a little different. So let's create foods, and let's do an array. We can do something other than food if somebody has a different, I like this one before. So let's do games. Right? I'm sure we've got some gamers here of some kind. So give me some games that you like.
God of War.
What? God of War. All right.
Street Fighter.
Street Fighter. Pac-Man. Pac-Man. Mega Man. All right, I like this.
Beating myself there, I think.
Another one. Pac-Man wasn't. Sonic.
Pac-Man's still in the arcades right now, man.
All right. All right. So we have an array of games here. That's awesome. So let's create another array or something else like this, and let's assign it to games. So games 2 has this array of games as well, right? Now, the difference here was when you're working with these primitive types, they store the value. And when you're working with these more complex types, arrays, objects, anything like that, they store a reference to that object and those values. So let's add another item to the end of this. Somebody else give me another game that they like. Final Fantasy. All right. So now let's look at games. And we see we've added Final Fantasy to the end of our array. If we look at games 2, what do we think the result is going to be?
It won't have the Final Fantasy.
God of War.
Do you notice that it also has Final Fantasy in its array, even though we didn't explicitly add it to games 2? This is the difference. This is the difference between these primitive types and the way that they work, or the difference between working with types that work as a value and things that work as a reference. So, and this is, like I said, this is a hard concept. We're not going to spend forever on it today. We'll definitely get into it more. But this is a hard concept. Or one that will trip you up. One that trips up experienced programmers, especially when they're changing languages and don't understand how it works in that language in different contexts. So you could think of it here again, we've got our big memory or whatever. So you could think of this as when we did the foods, we did food, and it stored fish and broccoli. And then when we created food 2, what it did was it got the value fish and broccoli because it's a primitive type. And food 2 in memory is like this. So we have essentially 2 places in memory that have that item, and they're pointing to different locations in memory. Whereas with our games, created an array. And the games array pointed here, if you will. And this is, I'm going to call this an array and just have it go down a little bit, but we'll put a few in here. Mega Man and Pac-Man and God of War. And because arrays, objects, things like that are these reference types, they're not a value, then when we created games 2 as a variable, it didn't copy these into another place and then point to there. Games 2 pointed to the same place in memory as games. So since they point to the exact same place in memory, anything that we change in one of them will change in the other one, not because we're making the change to 2 different things, but because we're changing it in one place and they're both reading from that same location. Whereas with these primitive types, it actually copies it when you do that sort of assignment. And then when you're changing it only in one place in memory, just like before, but the other one is pointing to a different location in memory. And that's sort of the difference between working with values and working with references. The reason, I mean, there's a lot of reasons, but one of the main reasons that that sort of thing exists is you can imagine, let's amp up our scale here. Let's say we have a list of every video game ever released. I don't know, every video game ever released for the PlayStation 2. We'll make it somewhat reasonable still, right? What's that? Probably like 3,000 games or something, I'm guessing. That's a long list. That's a really long list. And so if we created a second variable that equaled that list of items in our program, in order to work with it, it would take a lot of work to copy all of those values from one place in memory to another place, have a second copy of all of them, and then work with that copy of all of those values, right? That's a lot of processing power to do that. It's a lot easier instead to just have them both point. If you're saying, oh, this is the same as this, say, oh, well, just point to that same location. That works just fine. I didn't have to copy any of those values there. I've got a second reference to it. And now I can change stuff. So that's one of the main reasons that that's sort of something that happens. There's a lot of optimization that can take place as a result of it, but there's a lot of weird behavior that also happens as a result of it. So we have games. We have games too. Now let's do games.sort. So it changed the order of the items in this array, right? And what's going to have happened to games too? The same, because it's been sorted. That's cool. But now let's get into where this can really get tricky for you, right? Let's say we create a function. And it's going to, what do I want to do? Remove 1. So it's going to remove an item from an array, right? Array.pop, which is the way to remove something off the end of an array. So this is pretty simple. So we have games. If we call remove 1 and pass in games, our array, now games has one fewer item in it. We popped off Street Fighter, right? Because it's not there anymore. But that's where it can get really, really, because remember we talked about before that inside of a function, you're not really manipulating the values outside. Like you're not changing something external in a sense, and stuff's local scope. Well, we passed in array. It looks like a local variable. It is a local variable. And then we popped an item off of it, but it changed the value of what games had externally. And that's because when we passed it in, it did this exact same thing. It created a local variable in that scope of the function called array, but it still pointed to that same location in memory. And so since this still points to it externally, this points to it internally, when this changes the values, it'll affect what the variable external to that function was pointing to. So that's where you'll probably get hung up a fair bit on this type of stuff, where you pass something in because it's one of these more complex objects. It's not a primitive type. It's passed by reference in a sense. You make changes to it and you don't realize, oh no, I didn't realize I was actually changing the value outside of there. I thought I was working with a local variable and only changing something local to this function.
Are you able to erase like a specific thing, or do you just erase whatever?
Oh, I'm gonna give you guys some good program assignments around that. I wanted to do a lot of stuff around functions first to get people comfortable with them before I add arrays into functions and before we start doing more complex work with that. Yeah, what you'll probably get today is a series, and I'll have more, but we'll probably have a series. So I showed is-odd. We'll create functions of is-odd, is-even, and then I'll probably have one that's like get all odds and get all evens or something like that, and that will take an array of numbers, and then what it'll want is return back an array of only the odd numbers out of that array. Return back an array with only the even numbers out of this array. And you could write that the complex way by hand, but when you've already written an is-odd method or function, why not use that is-odd to do the check inside and stuff like that? So it'll help teach you how to compose stuff step by step too. Yeah.
Run games to,
Oh, I just texted it.
if you add something or remove it, will it change original games?
Yeah, let's look at that. I need to recreate these. I'm gonna put that K on Pac-Man. Create this. Let's create games2 equals games. So games2 dot push. Let's add something to the end here. Anyone have a game?
Verizon.
Horizon. We're going more modern now. All right. So let's look at games. And sure enough, in there. Because they're just pointing to that same location in memory. So, yep. All right. If there's no other questions about that, I'm going to go ahead and end now so that I can take some time.